right, so most of you are probably already familiar with Ryan and I because we've done this conference for quite a number of years, but I'm Sue Stankovitz. I'm our North American sales manager. Ryan is our applications engineer and customer support manager. So he's going to do a lot of the talking today. I'm going to be answering some of your questions, and we'll see if we can give you guys an enjoyable and entertaining presentation.
All right, so yeah, as Sue mentioned, Midnight Solar, you guys are all probably pretty familiar with us. We make a lot of stuff all the way from, combiner boxes up through to power electronics. We're going to focus mostly on the DC stuff today, charge controllers predominantly, and how to properly size those charge controllers. We're going to talk about some of the gotchas more than anything. Most of the common stuff is pretty straightforward, but there's a lot of little things that tend to bite you as you go. So along through here, I'm going to throw in some of our product. We're going to talk about that a little bit. This is our smallest, most inexpensive charge controller. It's a PWM 20 amp charge controller with a 10 amp load circuit. It will do a 12 or a 24 volt battery. It'll do flooded, gel, or AGM. It will also, if you don't need the load circuit, you can parallel that in and make it a 30 amp controller if you want to, and it is outdoor rated. So just real quickly, I'm not going to spend a lot of time on this, but you've got you dial up here to set your load settings. You've got your dip switches to set all the different parameters, battery chemistries, and then you got your terminal block here. And there's a bunch of LED lights up top, tell you what's going on. The nice thing about the Brat for me is that if you lose the instructions, everything you need is printed on here inside, so you can set it up without really going to get the instructions. And that's just a quick example of all the different options for your lighting, like turns lights on for 6 hours at dusk or turns lights on for 3 hours at dusk and 1 hour before dawn. I'm not going to read them all to you. That is in the manual. If anybody has any questions, they can definitely find that. Just a real versatile little PWM charge controller. And one of the common questions we get with PWM is, can I use a 60 or a 72 cell module on a 12 volt battery? And historically, you'd hear no. People would say, no, you can't. But in general, you really can. It's just not as efficient. And what I mean by that is a PWM charge controller connects the solar module directly to the battery. So if you've got a module running at 50 volts, for example, and you connect it to a 12 volt battery, your module will go to 12 volts. So your module might have a 9 amp, maximum power point current, if you will, but you're only going to get that 12 volts. So you'd get your 9 times 12 instead of 9 times 50. So it still works just fine. It's not as efficient. But the reason I bring that up is because the small modules tend to be a lot more expensive per watt and a lot less common. So, it does work. You'll see a little bit of comedy in here. I'm not going to go into the whole, backstory of this, but, be aware when you're doing the stuff that, the solar module does need to be in the sun. So I don't know how well you can see that picture, but up there on the pole is the solar module, and this is inside a parking garage running a street sign. Doesn't work very well. So we're going to talk a little bit about the KID. Again, everybody's probably pretty familiar with this one. I'm really going to try to push through here a little bit and get you some of the new product at the end. But the KID is a 30 amp charge controller. Do 12, 24, 48 volts. It's good for about 500 watts on a 12, 1,000 watts on a 24, 1,500 watts on a 48 volt. It does have a pretty sophisticated lighting controller. It has an automatic generator start with feedback, and it does connect to our Whiz-Bang Junior. Now, that last bullet point is not actually true. It is not available for wind or hydro. I need to remember to move that out of my slide deck. One of the things I like about the KID is the little LEDs. So, these top three right here are probably the most common, the most valuable for me, because the green light here comes on if it's gone to float. So if it goes 7 days without going to float, the orange light will come on, which will let you know at a glance that it's been 7 days since you've been to float, meaning you haven't had a full charge. So that's kind of a nice little thing to look at, quick at a glance. So blue light comes on if the load circuit's active, and the OVR light comes on if you're, over the current limit of the KID. And that's something to point out. I think I talk about that later in here, but as you look over this wiring diagram, all of our charge controllers, be it the Kid, the Brat, the Classic, the DIY, any of them will tolerate being over PV. They regulate very well. And if you're doing an off-grid system and you want to throw a little extra PV on it, so on those bad days you can get some extra harvest, you can absolutely do that on any of these controllers. You just have to be mindful of the voltage. That's really what kills charge controllers, is too much voltage. And we'll talk about that later. But this is just a little diagram, shows, use the proper breakers. That's a pretty common issue we get a lot when calls come into tech support. You'd be surprised at how few people, especially the people doing it themselves, don't install breakers. So, if you're selling a bunch of equipment to somebody and they don't have breakers in there, ask them, hey, you sure you don't need some breakers for that? So we talked about this a little bit just a second ago, but it's called overdriving the charge controllers. And just like a grid tie inverter, our charge controllers can handle being overdriven. Now, I do want to caveat that with saying not every brand, every manufacturer will tolerate that. Some will regulate a little slower and you'll get nuisance tripping of your breakers and stuff. So, if you're not using a Midnight product, definitely talk to the other manufacturer. Don't take my word on that one. But our products will definitely do that. If you're doing a battery-based grid tie, though, you really don't want to do an overdriving, because then you're losing production. When you're doing off-grid, though, a lot of times it can make a lot of sense to overdrive a charge controller rather than putting a second one in, because you don't need that production on a really sunny day, but on a bad day, you need it. So we're going to talk about the DIY. This is a new addition to our offerings, if you will. We have a line of product we call the DIY, and it is a Chinese private label product. It is a pretty decent quality, I got to say. I mean, we've punished this stuff like crazy, and we haven't really had any issues. We've had, I think, 4 RMAs total over all of the thousands of units we've sold. We had one charge controller that was massively overvoltaged. So that's not the charge controller's fault. We had one the display didn't work in, so that is a defect. And then we had one inverter that didn't have anything come up on the display, but we found that we could update the firmware and it worked just fine. And then we had one inverter that the aux relay for the gen start got stuck. It basically welded the relay. I'm still suspicious on that one that the installer, the customer may have tried to run too much current through it, and it is just a pilot relay. But that's it on those. For I think about over 1,000 units out the door. Those are the 4 that we've had any problem with. We do get a lot of questions on the warranty being shorter, and some people may or may not be aware, but when products are built, be it ours, Outbacks, Magnums, anybody's, the price of the product includes some money in there for tech support and for warranty. There's a certain amount of, okay, if we're going to give a 10-year warranty, we get up the price a little bit to cover that. And that's how we're able to keep the price down on these DIY products, is a smaller warranty. We're not saying they're not going to last as long. We're just saying that, hey, by keeping the price down, we can give you a shorter warranty and a lower cost product. So this particular one's 150 volts, 12 to 48 volt nominal battery that is compatible with lithium. It has a LCD display, as you can see, and it does have an optional Bluetooth, and does come with a battery temperature sensor, just like any other MPPT charge controller. It is MPPT. We don't actually make that a bullet point, but it's in the title. And there are no fans on this, so it is a 60 amp convection cooled. I've been punishing one of these quite a bit and had really good luck with it. You do have to obey that 150 volts. When you crest over 145, it's not going to turn on. And at 151, you're risking damaging your product. So that's what I was talking about earlier when I say we have to be conscious of voltage. Voltage is what we're really concerned about. So we're going to talk a little about voltage real quickly, and then we'll go back into some other stuff here. But the max VOC of your module is what you're really watching for here. And something to be aware of is sometimes you'll hear something like, this is a 200 volt charge controller. But if you read into the print and into the data sheet on it, you'll find out that it stops at 187 volts, not 200, for example. So you have to be real conscious of your product and what it actually does. Just because it has a voltage labeled on it, just like our DIY inverters we'll talk about here in a little bit, you have to look at the data sheet and see where's my MPPT window, where's my max VOC, and those kind of things, and design your array around that. Do you use the record cold to calculate or the average cold? It's going to depend on the product. Classics, for example, have hyper VOC. You can push it a little bit, and on a really brutal cold morning, they just won't wake up for a little while. But the on other products like the DIY, there is no headroom, so you need to make sure you're using the record cold. So when it's negative 27, like it was at my place this morning, it doesn't go over voltage and blow up. The other thing to be aware of, and this gets missed a lot, is the minimum VOC for hot days. So, I probably should have started with, but a solar module, its voltage will fluctuate with temperature. So a module, if it says it's 44 volts open circuit, that's at standard test conditions of about 70 something degrees Fahrenheit. So as it gets hotter, the module's voltage will drop, or as it gets colder, the voltage will rise. So most of your MPPT charge controllers that are on the market today require at least 133% of the battery's voltage to actually wake up, and you leave them a little room to work. So, and when I say the actual voltage, I'm talking about the target. So if you have a flooded acid battery and you want to equalize to 61 volts, you need 133% of 61 volts for that controller to turn on. So, well, I guess you see down there where I said 62 volts would need 83 volts actual on the hottest summer day. So those are a couple things to keep in mind. Our string sizing tool takes that into account pretty well, but you always want to think about that. The things that we get a lot of calls on every fall, we start getting calls that the batteries are being overcharged because the temperature compensation is rising the voltage on the battery. And every spring we get calls that the batteries are being undercharged. During the summer, sometimes we'll get a call where the charge controllers aren't actually waking up because the voltage is too low. And then we occasionally get calls in the winter where they're in hyper VOC or they're over voltage and won't turn on. So a lot like a solar module, a battery is a little bit backwards, but a battery, as it falls below that standard test condition, or that 70-ish degrees Fahrenheit, 25 degrees C, it needs a little higher voltage to properly charge. It needs to be pushed a little harder. And if it's above that and it's hot, it needs a little less. It doesn't need to be pushed quite so hard. So all your common charge controllers will do that for you, but that is sometimes alarming to new customers when they see their voltage going above their set point and they're not sure why. So I think most of you probably got the DIY session yesterday, because we are talking about DC charging. I did want to throw just a slide in here. And basically, we have a couple options here. We have a 3,000 watt 24 volt and a 5,000 watt 48 volt all-in-one inverter with MPPT. The 24 volt unit has a 100 volt MPPT. I believe it is 85 volts and below operational. The 5,000 watt is a 500 volt MPPT, and that is, I think, 450 volts and below operational. We will have about an 11 kilowatt split phase with dual 500 volt MPPTs coming out here, hopefully in another 4 or 5 months. So again, back to talking about, arrays and voltages and amperages. One of the things that comes up a lot, and I see a lot, is a solar salad. And that, it's a term, I don't know who coined it, but it's been around the industry for a long time. As modules got less and less expensive, this is getting more common and less common, if that makes any sense. So with modules being as inexpensive as they are now, some people are just saying, hey, let me take all the old modules down, sell them on eBay or Marketplace or whatever, and I'll just replace everything. But then some people are trying to mix and match what they have and what they want to put together. And the thing to remember here is that your strings, each string has to be within a certain voltage of each other, but each module in that string has to be within a certain current of each other. So as you see here in example 1, string 1, you have 36.2 volts and 4.5 amps, but all 4 modules are uniform. So you have 144.8 at 4.5 amps. But then in string 2, you only have 3 modules, but it still comes out to 142.5 and 9.5 amps. So those two strings will parallel very nicely. and the current will add up, and you'll end up with your, was it 14 amps of current and 143, 144 volts, VOC. So the rule of thumb here is if the modules are going in series with each other, the current needs to be within about 10% of each other. If the strings are going in parallel with each other, the voltage of the string needs to be within about 10% of each other. So that's just something to think, keep in the back of your mind when you're looking at these solar salads, and when you're looking at modules. If Alti has a deal and they only have 3 of a certain module left, you're like, hey, I don't care, they're going on my barn roof, I can't see them. You can start figuring out how you can make these things work together with a charge controller. The problem is if you start getting these 2 voltages too far apart, when the charge controller does its tracking, it will find both power points, and one of them may be way less efficient than the other. So in this case here, let's say the top array was 140 and the bottom one was 160. It might lock onto the top one and only make the 4 amps, whereas if it locked on the bottom one, it makes 9 amps. But if you get them close, it'll make the whole 14. So it's just important to get those close, otherwise it will confuse your charge controller. So I'm going to go through the Classic real quick. I think you guys are probably pretty familiar with it, but it comes in a couple flavors. We have a regular and an SL. The SL is what we call a solar-only version, and it basically does everything the standard Classic does except for arc fault and Ethernet, if I remember correctly. It doesn't do the auto EQ, it doesn't do wind or hydro, but those 2 items can be activated in firmware if you want, but the Ethernet and arc fault are physically not on board. So both of those come in a 150, a 200, or 250 volt operating, voltage. The 150, of course, runs up to 150 volts and so on. They all do 12 to 72 volt nominal battery banks. But if you're doing a 72 volt battery bank, you probably want the 200 or the 250, because you're probably not going to be able to get your PV voltage high enough on a 150 to properly charge a 72 volt. The standard Classic comes with the DC ground fault protection built in and the arc fault protection built in. The SL comes with just the ground fault. And like I said, solar, wind, or hydro modes, and you can activate the wind or hydro on the SL. Manual or auto EQ. One of the nice features of the auto EQ on the Classic is it does have a function called retry days. So if you tell it to EQ every 30 days and then retry for 3 days, on day 30, it will start an EQ charge. And if it's cloudy or something and it doesn't accomplish it, it'll try again the next day, and it'll try again the next day. So that's kind of a neat function. Along that same avenue, but completely backwards and different, it also has a function called skip days. And skip days, what that does is it ignores the bulk absorb cycle and goes directly to float. So let's say you've got a big lead acid battery bank, a whole bunch of PV, and very minimal loads, or you've got a camp that's unattended a lot of times. You can set skip days for 5, 7, 15, whatever number the battery manufacturer likes. And what it'll do is every morning it'll wake up and do a float charge until it hits that number of days. So if you set it for 15, it'll wake up and float 15 days in a row, 14, and on the 15th day it will do a full bulk, bulk and an absorb charge, and then go to float. It will also still follow rebulk. So if you were worried that, okay, somebody shows up at the hunting camp and uses a bunch of power, you can set rebulk so that will trigger another full charge, regardless of the skip days. But that skip days is kind of a nice function for a lot of places. Fully internet capable, only on the regular Classic, but it does have an Ethernet jack, plugs into your local network at home. You can then see it online at My Midnight. You can use the local app software. We have a Bluetooth dongle that I believe will probably get finally released here in the next month or so. That will be locally only, so the dongle will plug in the Classic, and you can, within 100 feet of the Classic or whatever, you can connect your phone to it and monitor, look at the logs, change settings, etc. The display can be remoted on the Classic, or you can have 2 displays if you want. The Classic stores 380 days worth of data, 24 hours Let me start over with that one. The Classic stores 380 days of daily history, and then it stores 24 hours of minutely history. So at the end of every day, it takes, like the kilowatt hours for the day and the high battery voltage and things like that, and stores that for 380 days. But every 5 minutes, it will take a snapshot of everything that it's doing, and it just overwrites that. So it stores 24 hours, the last 24 hours. It does do Modbus over Ethernet and Modbus over RS-232. That is an openly published protocol if you want it. And parallel operations for multiple Classic systems, we call it Follow Me, requires a simple phone cable. So again, following the max voltage the manufacturer calls out. Make sure you're using gear that's DC rated. AC is definitely not the same. I mean, I've seen a lot of people, using square D breakers, and I know they carry a little bit of a DC rating, but usually your overcurrent protection in DC is not a place to cheap out. Is your overcurrent protection load break rated? That's another one that's important. When you're looking at El Cheapo DC breakers on Alibaba or something to try to save a few bucks, are they actually load break rated? Are they listed? Look for those things. And then the last, point I want to make is following the voltage of the system. How do you pick your parts, right? So let's say you're going to do a PV array that's 100 volts VOC, and you're going to do a Classic 150. That's kind of a poor example, actually. No, it still works. Let's say you do the PV array of 100 volts, you do a Classic 150, and you say, I'm going to put a SPD 115 on that because it's 115 volts. The array is 100 volts. And it works perfectly, right? But the problem with that is that then if somebody else comes behind you and puts one more module in series, they've exceeded that 115 volts. So that same holds true. Let's say you've got a 1,000-volt string inverter, but you're only running 500 volts into it. Don't use a 600-volt combiner, because if somebody comes behind you and doesn't pay attention to all the parts and components, they could run that PV array up over the 600-volt limit, and you could run into trouble. So I guess my long and short point of that topic is that I like to design the system around the MPPT device, whether it's an inverter or a charge controller, its voltage. So if it's a 250-volt Classic or a 300-volt Outback or whatever that case may be, I like to design everything upstream of that around that voltage, and that way there's no surprises if somebody does anything to alter the array. And the other one is just finding out what the voltage of the equipment is. This particular combiner box we're looking at here that you can see caught on fire, those fuse holders in the front of it say they're 1,000-volt DC. But the box, and it is clearly labeled on the box and marketed as such, is only good for 600 volts because of the DC switch. The installer saw the 1,000 volts on the fuse holders and didn't look at the label on the side of it, and when the switch opened, it caught on fire. So you do have to pay attention to all the markings and labelings and everything like that. A lot of times you might even start seeing 1,500-volt fuse holders. I don't know, but that's, you just definitely know the voltage ratings of your equipment so you don't get yourself into some mischief there. Definitely use DC rated gear. Make sure your breakers are load break rated if you're using them with a disconnect. And that should keep you out of most of your mischief there. So do you need a combiner box? If you're doing 6 strings of PV, couldn't you just do this? Electrically speaking, you could. Safely, you cannot. So in a PV array, if you have one string, it'll have something called a short circuit current, usually 15 or 20 amps. If you have just 2 strings of PV, then you can get away without a combiner box, because if there's a short in one string, the second string is only good for 8 or 9, maybe 10 amps. So it's below the rating of the string, the other string that has a short. So the other string will just absorb the current and never catch on fire, never have a problem. But now let's say you have 5 strings, and each string is good for 10 amps. When one string shorts out, those other 4 strings are going to put 40 amps back into that one string. And now you've exceeded its safe rating, and it is going to heat up. It is going to catch on fire. So in general, it's mandatory to have combiners and overcurrent protection on 3 or more strings. I find it very handy even on 1 or 2 strings. It's just an easy way to disconnect things, troubleshoot things, make things safe downstream. But the one thing that I see gets missed a lot is batteries. And I don't know how many systems I've seen with multiple strings of batteries and no overcurrent protection. And the same really kind of holds true there. If you've got, 8 strings of batteries and one string has a problem, the other 7 strings are going to gang up on that string and you're going to have a big old meltdown. But if each string had a properly sized overcurrent protection, when that one string had a problem and the other ones tried to gang up on it, that overcurrent protection would open and, problem would go away. So that's just something to keep in mind. And we talked a little about why you need the combiners, but I left this slide in here. You need to know what you need for a combiner. We have almost anything you could want for combiners. If we don't have it, Alti can tell you who else makes it and get it for you. I'm positive. You can use them as pass-through boxes. You can use them as load centers. Some of them can be reconfigured for, like the one on the left there, 5 strings into one inverter and 5 into another. But we have things from 150 volts all the way to 1,000, 2 strings all the way to 12 strings. So don't be afraid to reach out to us when you're getting into combiner selection if you have any questions. But again, just make sure that it does what you need it to do, voltage and current wise. And then also make sure it'll do enough strings. And what I mean by that is we're probably the most guilty party, but we have a combiner box we call the MNPV6. So you would look at that and say 6 strings, right? And it is if you use breakers, like you see down the bottom right corner there. But if you use fuse holders, it won't hold 6; it only holds 5. So you have to look at the specs on the box, I guess is what I'm saying. If I can find my mouse on that white screen. So now I'm going to spend a little time talking on a couple of the new products we got coming out, and then I'm going to turn the floor over to Sue for question and answers, and we'll see if you guys got any questions for us. So I'm going to talk about the Hawke's Bay first. The Hawke's Bay is a 600-volt MPPT charge controller. It will track all the way down to 140 volts. It comes in 2 flavors. It comes in a 90-amp semi-sealed unit. And when I mean semi-sealed, like don't put it out in the water or underwater or anything like that. It's not physically sealed with gaskets, no rings. It's just, sealed up. Kind of like, not quite as good as the old FX inverter, but close. And then it comes in a 120-amp vented model. They both have 3 auxiliary input outputs. They also have remote voltage sense for the battery bank. It comes with the MNGP2, we're calling it, that display with the round knob and the push buttons. And it does have internal fans. We talked about it being sealed or vented. It does have a matching die-cast breaker box like you see in the picture here. So it's a pretty big unit, but it's not huge. I would say the Hawke's Bay is roughly 16, 17 inches tall, probably 8 to 10 inches wide, is my guess. But remember, it's 120 amps at 600 volts. And they will be arc fault, ground fault, and rapid shutdown modules that you will plug in as option boards. The ground fault meets all the new standards where you can actually solidly ground the negative and it will still, work because it's measuring the differential current. So this one's really cool. It's really close. It's working really well. The plan right now, if I remember correctly, is ETL came in and did all of the evaluations about a month ago. And we had one quirk with the high pot testing. And they have redesigned the board. Everything is perfect there now. And ETL comes in next week to verify that. And once that's done, we will have our report and we'll be ready to go. Production line is set up and we anticipate being able to start moving these out the door by the 1st of April is our plan right now, unless some major glaring issue pops up, but it just hasn't yet. So we will keep an eye out for that. We have a couple questions. What battery voltages for the Barcelona and the Hawke's Bay? So currently the Hawke's Bay and the Barcelona are going to be 48 volt only. As we move forward, we may release a 24 volt version of that as well, but for now it'll be 48 only. And I'm being asked if they can be used for wind or hydro. And out of the gate in April, the answer to that would be no, but wind will be coming very quickly behind that. We have to make some modifications to our current clipper to support 600 volts. and then we have to add the wind tracking into these products. But that is the goal, is probably 3 or 4 months down the road to have wind in those as well.
And we do have a number of these out in the field with a couple of beta testers and several with our employees. So we do actively have these working and functioning. So we're very, very excited to get these released out to you guys in the public and let you guys see what you can do to break them as well. As with any new product, we do expect there'll be a couple of quirks at the start, but we are very excited to get them out to you guys.
And I do have a question back on circuit breakers. Well, it's more of a statement, I think, or I guess it's a question. The example of overcurrent protection with multiple strings of PV, would not the back feed on a circuit breaker be an issue? And so what the question here is if you look at this top picture up here, if you can see my mouse, we've got 3 circuit breakers and we got a bus bar. And you might or might not be able to see it in your picture. I just know it's there because I know the product. There's a little plus emblem. Oh, I lost my mouse. Well, you might just have to believe me on that. I can't get my mouse back. There's a little plus emblem on the bottom of each breaker. And yeah, right there. There's a little plus emblem there, and that is a side with the greatest potential. So that's coming from the PV array. So the power is coming in here, going through the breaker, through the bus bar and over to the charge controller. So now if this string here shorts out, these 2 strings are ganging up on it. The current's flowing back this way to try to gang up on that, and this is going to open under load in a reverse polarity situation. And so in your mind, you would think that's a bad thing, but there's no problem with that. That was fully tested by UL. The reason we have a polarity is repeated use. These breakers are rated as a switch as well. So if you use them 10,000 times in that case, you may get a little more arcing on the contacts, and before you know it, you've got a bad breaker. But in a one-time use like that, you'd never have a problem. The good news is these breakers are being phased out over the next year and a half with a breaker that is non-polarized. So then that issue goes away. Well, that concern goes away, I should say. It's not an issue, but the concern goes away. So we're going to go on. One thing I wanted to point out on the Hawke's Bay and the Barcelona before I get too far down the road, we've been approached by many lithium battery companies, and one of the problems you'll have with a lot of these charge controllers, be it Midnights or anybody's really, you've got such a high voltage on the input. If there is a catastrophic failure internally, there is that potential for the output to go to an uncontrolled high voltage. We've not seen that, I don't think, in the Classic line, but we've definitely not seen it in the Hawke's Bay, but we do understand how that could happen with the right amounts of failures in components. So one thing we've done in the Hawke's Bay and Barcelona is we've built in a self-powered circuit that monitors that the battery voltage. And if the battery voltage terminals go above a safe voltage, it remote trips the breaker down here in the breaker box for those 2 devices. So it's just another step, because one of the things that was brought to our attention is not every BMS will actually safely open if the voltage is spiking quickly. They'll arc over and then bad things can happen. So that was a feature that we were requested to put in, so we went ahead and put it in. And the Barcelona, I apologize, I did not get a picture for this slide deck before I started. I meant to. It's about probably 4 or 5 inches wider than the Hawke's Bay. Same height, same depth up the wall, just a little wider. And you'll see one here in a minute. It's the same 600 volt input, same tracks down to 140 volts. The difference is it has true dual MPPTs. So it's 190 amps of total current output, but 95 amps per side. Or they could be paralleled if you had one really large array and you wanted to, combine that all together. Generally, I wouldn't do that unless the reasoning was you had wires already run or something and you couldn't, run more wire. Because anytime you can split the array and track it independently, for soiling or shading or any other reason, you're going to be a little better off. But you can parallel it. Or you could do say, a wind turbine on one side and a solar array on the other. That's kind of a neat feature. The same 3 auxiliary inputs, same remote voltage sense, same MNGP2, internal fans, et cetera, same option boards. Matter of fact, the Hawke's Bay and the Barcelona use the same control board, same exact everything. So if you had a control board go bad in a Hawke's Bay, you could take one out of a Barcelona and throw in it, keep on going. They all speak CAN bus too. All the new Midnight products coming out this year speak CAN bus, and they all just daisy chain together. There will be a comms box to connect them back to a classic or do closed loop systems with different lithium batteries, etc. So we're really excited about these. The Barcelona is probably a couple weeks, 3 weeks behind the Hawke's Bay, but they're both, like I said, being evaluated next week by ETL, and we should have, unless something really goes horribly wrong, we should have a listing on both of those next week. And I do have a question about the arc fault. Is it series or parallel, and how does it shut down the modules? So the arc fault is I would say series, because a parallel arc, well, I guess it depends how you want to call it, but it's looking for a loose connection. So if your plus and minus out in the array start shorting together, it will see that, and it will open the relays, let's say actually solid state relay inside the charge controller, and quit loading the array, but it's not going to prevent the fire. The only way to do that would be to short the array out. So it's just like any other arc fault. All it's doing is unloading the circuit and trying to extinguish that arc. So it'd be for a bad MC4 connector, a loose connection, something like that. It wouldn't be for when a positive and negative short together. That was deemed by, I guess, UL to be not worth the cost to, protect against, basically. So nobody's ever done that. The aux outputs on the Hawke's Bay and Barcelona set to 12 volt, just like the Classic. Yes, all 3 will be 12 volt out or a logic input. There are no relays internal. It'd be up to you to use your own relay. And how does the rapid shutdown work in the Hawke's Bay and Barcelona? So there's a toroid in a little plug-in board that snaps in. I can't really show you in this picture, but I might be able to in the next one. It plugs in inside in the wiring compartment. And you can almost see the toroid right in behind all that mess right there when Mario had everything tore apart at my place. And what that toroid does is it injects the SunSpec signal into the PV line, and then you use your favorite receivers out at your PV array. And when you send a kill signal to the charge controller by opening 2 wires, the system shuts down. So if you had a whole Midnight system, all systems would intertwine together. If you had just a Hawke's Bay, for example, then you'll have a 2-wire circuit. You use your favorite lockable push button outside. And when you shove that button and open that circuit, the rapid shutdown, signal goes away and the system shuts down. So it'll be a pretty elegant solution when it's done. Like I said, if you've got a complete system, the inverter can shut down. You can program it to shut the inverter down or not shut the inverter down, depending on your, feelings on that. But yeah, we're really excited about those 2 products. Those are, like I say, long time coming, but real close. So I think that's the end of my slide deck. I will check it out in just a second here. Oh, I'm sorry, I had SPD still to go. Not paying attention here. So I don't know how many here are not familiar with our surge protection devices, but they're very cheap insurance. They work well, very robust. Of course, there's no guarantee against lightning, but you can, try to do your best. We have had some that have actually been hit by lightning and saved equipment. We've had some equipment fail when it got hit by lightning, of course. Like I said, it's a direct hit, all bets are off. But I'd venture a guess that 80 to 90% of the damage caused by lightning is not a direct hit. It's induced voltage from a nearby strike. And in that case, they're going to work great. I usually save the 115 for something odd or, off the wall, really low voltage. Pretty much always use 300s on my DC charge controllers, unless it's a 600 volt controller and they use a 600. There is a AC and a DC 300. They're physically identical. The difference is how the LEDs light up. So, they both can be used in either application, but we made both because people were calling us and saying, I only got one LED on my PV array. How come? And that's why we made the DC, so you'd have both. So these are not just for renewable. They're great for, even a grid connected home with no solar. They work really well. I use one on any house I ever wire. It's just a cheap insurance. Indoor and outdoor rated. They are a 4X enclosure, so they can go outside without another enclosure. They have to, of course, bolt into something, but like a combiner box. So then in closing, I'll leave you with this one. And this was given to me by an electrician friend who, I don't know where he got it, but it comes from a mill application where he went to work on a motor, and the motor, he opened the disconnect, locked it out, and then he found, when he got to the motor and went to check for power, he found that he still had one phase live. So this is why I say I always check. Don't ever trust a switch. I always check yourself. Don't even trust your buddy. If he says, yeah, I turned that off, grab your own meter and check it. So yeah, I'll leave you with that. And then
I do have the question, will this presentation be available for review on a later date? It is being recorded, and ALT-E will actually have all of the presentations from this entire conference available to you guys. So it's a pretty fun resource to have throughout the year. I think they leave them up for most of the year. I'm sure our moderator here can answer that question better than I can, but I do know it will be available.
And then we have a question about rapid shutdown. Can it break the circuit for relay protected modules? I'm not sure what a relay protected module is, but the rapid shutdown disengages the charge controller. So your charge controllers either have a relay in the positive line from the PV, or they have a solid state switch, if you will. Either way, it's going to open that circuit, and it's up to the modules to do whatever they do. If it's a SunSpec module, the signal goes away, they shut off. If it's some other kind of device, I'm not familiar with that, but there is a 2-wire kill on the system, and when you open that circuit, they will open their relays and stop charging. Firmware for the Classic. That's a great question. So we've been horrible at sustaining engineering, if you will. We actually just hired an engineer about a week ago, and that's all he's doing is the Classic. So I just gave him a list of bug fixes and everything else, and he's going through that. He's adding battery chemistry selection to the startup menu. So like, for example, if you select lithium, it's going to do the low temperature safety, the high temperature stuff. It's going to disable the temperature compensation and then allow you to set all that. So yes, you should start seeing beta firmware releases for the Classic. I'm going to guess probably in 2 or 3 months. Do be aware this is new, a new engineer, and it is new. The firmware is brand new to him, so he's just getting a grasp on the whole Classic stuff. And I think what you'll probably see first is a lot of the little bug fixes. Like if you watch the Classic when it's charging with the Whizbang Junior, before it's gone to float, it will flash the 100% state of charge, meaning that it is not calibrated yet, if you will. So we're going to change that from a flashing 100% to a flashing waiting. In that way, it's got to calibrate. So yeah, and I'm being asked about the rapid shutdown. Does it provide module level shutdown? It can, yes. So the Barcelona and Hawke's Bay will transmit what's known as a SunSpec signal, rapid shutdown signal. So you could use AP Systems, you could use the little Midnight SunSpec devices that are coming out this year, any other brand that is SunSpec related, and it would trigger those. So the charge controllers do 2 things. When you open the wire to tell them to go into rapid shutdown mode, they stop charging and open their internal relay, but they also stop transmitting the SunSpec signal, if you will. So it could be module level, it could be string level, just depends on what you have for devices on the roof to make them work. And do we have heated koozies in Maine? Rick's asking if we had heated koozies in Maine. It was negative 27 this morning. Hey, I'm in Florida. It's like 65 degrees here, so I can't feel bad about negative 27 in Maine. I think that's all of our questions.
Awesome. Great presentation, guys. Yeah, this is going to be super valuable, I think, for anyone that wants to learn more about using your products, especially for small DIY systems. Yeah, great stuff. Awesome. And we will have, to answer the question, I posted an answer as well, but we'll have these posted on our YouTube channel in the coming weeks, just in a big playlist for all the sessions from this year.
Yeah, and Amos just asked if the new charge controls are going to be manufactured in the U.S. And yes, absolutely. They're we've got 2 more buildings in Arlington, Washington, all set up. Starting to hire employees as we speak. And then there's a question about lithium iron phosphate cells becoming popular, and if we could go over the charging parameters. And I'm going to be hesitant to do that solely because even though they're becoming very popular, every manufacturer has slightly different parameters. So what I would say is that you can call our tech support department and ask them about your particular battery. You know, for example, like the Kilovolt, we've got a great white paper that we've done jointly with Kilovolt. Tells you how to program our products for that. We've done the same with Fortress, Simplify. So I don't want to go into, you know, hey, set it for 56 volts, because that's not a standard answer for lithium. It's going to depend on the battery, in my opinion.
Our tech support will give you a couple of recommendations on your settings in the Classic, for example, though, to help mitigate potential issues if somebody got to mucking around with your buttons. Because we all know every once in a while you have a friend who's going to come over and push some buttons. And one of the things we recommend, for example, is that your equalized charge, you go in and you set that to the same voltage as your absorb. And that way, if somebody were to accidentally trip an equalized, which you don't do on a lithium battery, then it would just essentially do another absorb charge. So there are a few things that we do recommend that you do with lithiums, just as little extra safety measures, like not using the temperature sensor because you're not going to do temperature compensated charging. So it is always welcome to call our tech support and have a chat with them and see what some of our additional recommendations would be.